Hello, guys. I want to hear from you. Where are you facing some challenges? Somebody is saying linear graph. Okay, right. All right, let's start. Let me just run through for those who are preparing for assignment number one so that they can also capitalize. Okay, no, don't worry. Don't worry. It's something that is so simple and straightforward. Okay. So I know most of us, we are now aware of BEM dust, FODMAS, or bomb dust. All this is one and the same thing. So first and foremost, when you are dealing with your calculations, okay, factorials, okay, I am getting you. Some they are saying graphs, some they are saying factorials. Okay, all right. So BEM does, it means we start with the brackets, we move on to the exponentials, multiplication and division, and addition and subtraction at the last. Okay, graphs is my problems. Don't worry, don't worry. I think once I'm done with this first session, the second section that I'm going to do with you, we are going to tackle that one. We are going to tackle that one. Okay, so that's the order. So now it says calculate the value of each of the following expressions, state the order in which the operations are performed, assuming that you operate from left to right when priorities are equal. Okay, so remember BEM task or robot mass. This expression first, you start from left to right, then you move on to this, you move on to this. Okay, so first we start with 4 times 3, we get 12. Then we divide that 12 by 2, we get 6. So we then say 6 plus, then here 5 times 6, that's 30, minus, then we've got 20 divided by 4, which is 5, then 5 times 2, which is 10. So if we are to say 30 minus 10, 6 plus 3, that's 36, minus 10, then the resulting answer will be 26. So take note of that. You start with this, okay? Then the following one, remember we said the exponents, remember it's D, E, M, G, A, S, okay? So brackets, do we have brackets? No, we've got exponents. So we start with dealing with the exponents first, okay? So now, this one, 3 to the power 2, that's 3 times 3, which is 9, times 7, minus, remember, root 9 is the same as 9 to the power half. Okay, so which is also, we need to evaluate this one first. So which is root of 9, that's 3 times 8 plus 2 to the power 2, 2 times 2, that's 4, divided by 4 times 3. So now we start with this, we move on to this, then this. So So 9 times 7, that's 36, minus 3 times 8, that's 24. Then 4 divided by 4, that's 1. 1 times 3, that's 3. So 36 minus 24, that's what? 8. Um, 36 minus 24, that's 12 plus 3, that's 15. So your answer will be 15. Okay, the reason why I started with this one, you see, the reason why I'm doing this, my friend, is because there are some way to write assignment number 1. That's why I started with this one. But I will go to the parabolas, to the graphs in the next lesson. So just be patient with others also, so that they can also see where they are lost or where they messed up. Like my friend here is saying, I see why I missed marks. I followed the BEMTAS, which messes everything. So you need to take note of that, because this part of the question, they will also appear in your exam. If you don't know how to tackle them, then you will also lose marks because of that. So yeah, thank you. 9 times 7, 63. Yes. Then 63 minus 24, that's what? All right, 66 minus 24. Our answer is equals to 42. All right. Yes. So you need to take note of that. All right, let's just move on. See where we will get. You see this expression. So we have got this bigger root, square root. Then we have got what is inside. So you start with what is inside extending to the outward. Okay. So like in this instance, if we are to say we have got our 3 that is in the bracket times, then you move on to what is here. Remember, there is another root inside. So you start with this one. So 4 to the power 2, that's 16, plus 3 to the power 2, that's 9. So you start with this, you also go to this one. So here, this one, they are all in this. Plus this one, what you do, you start by adding first. 4 plus 3, that's what? That's 9, right? Remember, B is brackets. So 4 plus 3, that's 7. 7 to the power 2, that's 49. So we've got 49. Then all these, they are inside a square root. Okay. Now you move on to this 16 plus 9, 25, root of 25, that's 5. So 3 times 5 plus 49. Okay. Now they are all inside this root. Okay. Now 3 times, now remember, now we have got this expression 3 times 5 plus 49. We use our left to right. So we start with this one. So 3 times 5, that's 15, right? So now it's now 15 plus 49. So 15 plus 49, what do we have? We have got 64, right? Then now you look for the square root of 64, which will give you 8 as the final answer. So you do piece by piece, piece by piece, piece by piece until you are at the final end. Okay? All right. So this is it. So let's look at this one. Okay? So we have got this divided by this. So we evaluate this bracket first, then we have evaluate this one also. Then at the end, we then divide. So if we are to look at this, we've got 4 squared inside. So 4 to the power 2, that's 4 times 4, which is what? 16 minus. Then left to right, we have this and we have this. Okay? So 6 times 3, 18 minus. Since we have got 80 here divided by 5, so 80 divided by 5, what do we have? We've got 16. Or they are raised to the power what? 2. These are inside brackets. Then you divide this one. Then you evaluate this one. 9 times 9, that's 81. Minus 77. So it's also in their own brackets. So here we evaluate this one. 16 minus 18 minus 16 is 2. Then 2 to the power 2, 4. Divided by 81 minus 77, we have got 4, right? Then 16 minus 4 is what? 12 divided by 4. Then your answer will be 3. So that's what you do. That's what you do. That's what you do. Okay, let's move on. Okay. Now, there are what are known as variables. So variables, normally they are represent unknown number. So if they say we've got a man has got a certain age, when you hear that, you know that you represent the age probably with any letter. So any letter, you might say X, you might say Y, you might say A, depending on the scenario that you are given. So that name will become a what? A variable. So it helps you to identify or to get the actual number that will be in the scenario that will be given. Okay, so for this instance, we have got x plus 4 is equals to 6. So x represents the variable that is unknown. So in order to find that x, then that's when we shift this 4 to here. So which will be x is equals to 6. Since it has got a positive here, when it comes to the other side of the equal sign, it will become a negative. So it will be 6 minus 4, which will be 2. Okay. Right. So sometimes they say the sum of a number and 6. So if you are to write this expression, you take note of the sum means add of a number. It means we don't know the number, so we represent the number either by x and 6. So we are saying any number and 6, the sum of those, a number and 6. So in other words, we are just simply saying x plus 6. That's what they are saying here. Okay, let's just move on. Here it says the sum of a man's age and half his son's age. So we say let the sum the man's age be, let's say, x, right? And let the son's age be y. Okay. So now the sum, meaning to say we are going to add. All right. But it says the sum of a man's age. So the man's age is represented by x and half his son's age. So half son's age. So that's how you write the expression. So sometimes they love to give you these scenarios, but you need to deduce your formula from there. So here they use the M and S. Okay. So here is simple stuff. Determine the numerical value of the following: 12x plus 17 if x is equal to 2. So what they are saying is substitute 2 where there is x. So 12 by 2 plus 17, which will give you 12 times 2, 24 plus 17, then 41. So that will be your answer. I hope so far everyone is following and no one is lost, right? Let's do together E. X plus 7 over 4 plus 3. This one, when x equals to 5. Anyone to contribute? So that I can see that you are also following.
Can I do that?
Yes, you can.
It's 5 plus 7 divided by 4 plus 3. And then you're gonna add the 5 with the 7, get 12 divided by 4 plus 3. 12 divided by 4 is 3. So it's gonna be 3 plus 3, which is equals to 6.
Yes, that's it. Okay. So someone to do F. F is F. Yes.
Greetings. My name is Lucky.
Yeah.
We say we substitute x by 6 in the bracket, which is going to be 6 plus 3
Mm-hmm.
in bracket.
Mm-hmm.
Then 6 minus 2 in bracket.
Uh-huh.
Then we say it's 9 in bracket.
Mm-hmm.
That's already yes. Then we say 4 in bracket.
Uh-huh.
Then we multiply by the 9 by 4, which gives us 36. That's the answer.
36. Yes. Thank you. That's it.
Thank you.
So that's all about this part. Okay. Let's move on. Okay. This one, some when they saw another one to contribute on B, A squared plus B squared plus C squared. Let's move, guys.
Okay.
Mm-hmm.
It's 2 squared,
Yes.
which is 4. Oh, sorry, because of plus
Mm-hmm.
1 squared
Mm-hmm.
plus 7 squared,
Mm-hmm.
which gives us 4
Mm-hmm.
plus 1
Uh-huh.
plus 49.
Yes.
The answer is 54.
Thank you. Another one to do D. 2B minus C plus 3 over A plus B squared. Other one to do D, this one. Yes, you can. Just unmute, then you speak. Malwakwan.
It's too big.
Here.
You said D
Yes, this one. I wrote it here.
is 2 multiplied by 1
Uh-huh.
minus 7 plus 3,
Uh-huh.
all divided by 2
Mm-hmm.
plus 1 square.
Yes. Let's move on.
Then
Mm-hmm.
2
Uh-huh.
minus 10 over 2
Mm-hmm.
plus 1.
Uh-huh.
Then 2
Mm-hmm.
minus 2 minus wait to stay. I don't see the lower hand. C7 minus 5
Mm-hmm.
plus 1.
Uh-huh.
Then the answer is minus 2.
That's it. So basically, that's what you all do. You just look at the question, what is it that you are given? Then you do what it requires. Thank you.
Sorry, sir. Sorry, sir.
Yes.
Before because you said that is minus 2. 2 minus 5,
Uh,
2 minus 5 is going to give us 3 plus 1, which is 4. Then the answer, I think, to me,
you are saying
it's not 2 minus 5 plus
Uh-huh.
1,
Uh-huh.
which is 2 minus 5, gives us 3 plus 1 and gives us 4. But it gave us the answer of minus 2. I
No,
think
remember, 2 minus
is
5. When you are dealing with addition, 2 minus 5, right? When you are dealing with addition and subtraction, especially when the signs are different, this one is plus, right? But we don't write the positive. So when you have got a scenario like this, what you do, you take the sign of the bigger number. So if you look at 2 and 5, which one is big? That's 5, right?
5.
Then
Uh,
you take the sign of the bigger
but,
number. Then after that, you then look for the difference. 5 minus 2, that's minus 3. Plus 1, we move on again. Sign of the bigger number minus, then the difference between the two, that's 2. Yes,
no,
yes.
thank
So
you.
don't be confused with this. Okay,
Okay.
yeah,
Thank you.
all right. Yeah, welcome. Let's move on. Right, these expressions, A, what is A? Another one to contribute.
It's x plus y because
X
it's
plus.
the sum of just x plus y.
All right.
Mm.
Then B,
Okay, that is subtract the sum of a and b from 8, which is 8 minus ab minus ab. Because say subtract the sum of a b from
mm. So you're
b.
saying
That's
8 minus,
8 ab ab
if you
ab.
if you say AB, it's A times B. Okay. Yes, Malwa Mashlakwan.
Yes, they say subtract the sum of A and B,
Mm.
which means we first add A and B, then we
Yeah.
subtract it from 8.
So we
We
want
first
to
add
know uh, A
A
plus
plus
B.
B
Uh,
inside the bracket,
uh,
then we subtract it with 8, minus 8.
minus 8, like
Yes,
this.
yes.
But here it says from.
Hmm?
So it means it's supposed to be 8 minus a in bracket plus b in bracket by a b in bracket. That's how it's supposed to be.
So where remember it says from. So what they are saying is this this addition, the answer that we are going to get from this one, we need to subtract it from 8. So meaning to say 8 is the one that comes here. Okay. So we are saying
And
8.
I don't think the bracket is needed.
Even if you put the bracket, it's still fine because you just want to identify that it's A and B, right? But still afterwards, after you have done like this, you then remove the bracket, minus A, minus B. Because if you put it like A minus A minus B, plus B, then B, it will give you the wrong answer. So the
Okay.
bracket
Okay.
is needed because we are adding A and B. Okay.
Okay.
Yes. So if you do it like A minus A plus B, then it means is the equation will be A plus B minus A, which is not true. What about D? Yes, yes, that's it, Mr. Kingsley. Yes. Somebody to try D. Yes, Mashwakani, you can speak.
But it's 7 multiplied by y.
7 multiplied by Y.
Yes, the answer is 7y. 7 years.
Are you sure? Robert is age in 7 years' time if he is now Y years. Now he is Y years. What will
It's y
happen?
plus
Can I try?
Yes,
I think it will be y plus 7.
yes,
We are adding instead of multiplying.
yes, that's correct. Did you get it? Because now you are Y years. Let's say you are 20 years.
Okay.
What years will you be in 7 years
Okay.
from now?
Okay. Now I understand.
You got it. Yes,
Yes.
that's it. So they just play with your mind, guys. So you just need to. Then there is what is known as laws of operations. We've got commutative laws. So a commutative law in simple terms is the sum of two numbers is unique. So what it means by this is that if you add A plus B, it must also be equal to B plus A. So we have got A 1 plus 2 is the same as 2 plus 1. So that's what they say unique. It always gives you the same answer. Okay. Okay. So that's cumulative. Yeah, I will send the recordings. Don't worry, guys. For those who are worried, don't worry. All right, let's move on. So that's what they mean by commutative. All right. So it also works also on multiplication. So A times B is the same as B times A. Same example that I gave. 1 times 2 is equal to 2 times 1. So you always get the same answer. All right. That's commutative. These are examples. Then associative or associate laws. Suppose for 2 days you have worked 5 hours per day at 16 rand per hour. How much money did you receive? So 2 times 5 times 16. So this one is associative of multiplication. So 2 times this one can be written also like this. 2 times 5 in brackets, then times 16. Then you are still going to get the same answer. Okay. So the sum of 3 numbers does not depend on which 2 are added first, and the result is unique. Same applies. So commutative, if you are to check, we had 2 numbers, A plus B, will always be equal to what? to B plus A. But on this one, we are saying if we add A plus B, then in brackets, then we add C, it doesn't matter if we also do the opposite and say A plus, then we put B plus C in brackets. All right. So same applies. The product of three numbers does not depend on which two are multiplied first and the result is unique. So same order again. All right. Let's just move on. All right. So there is distributive law. So far we have stated laws for expressions containing one type of operation only, either addition or multiplication. Let's take a look at combination of these two operations. So confirm if the expression to the left and the right of the equal sign yield the same. So this one, can you confirm that this one yield the same to this one? So let's go 6. Then we need to 2 plus 3, that's 5, right? 6 times 5, we've got 30 on this side. What about here? 6 times 2, we've got 12 plus 6 times 3, 18. 18 plus 12, that's 30. So this one is true, right? Or simply, you can punch through this one using your calculator and see this one and this one. Because I believe they also allow you to use a calculator. Okay. So this one, do we have the same results? This one. Okay, somebody saying yes. Do we all agree? Okay, saying 39.6 here. On this side, 39.6. Is it the same with this one? All right, perfect. So all we agree that the result is true. So that's distributive law. Normally, you can use it, especially when you are expanding or removing the brackets. Okay, so the product of a number with the sum of two other numbers is equal to the sum of the product of the first number with each of the other two numbers. Okay, so like this, what we are simply doing here is A times B plus C is equals to A times B plus A times C. Remember what I said? I said you are just removing the brackets. Okay. Okay, fine. So take note that these ones, they don't work, especially when you are dividing. When you are dividing or subtracting. So these ones, they don't work. Okay. And also the associative law does not work for subtraction and division. Then take note of these, the identity properties. All right. So any product, the product of any number with 0 will always give you what? A 0. Same applies whether it's an a variable, a letter that you are multiplying with a 0, it will always give you that. Then any number with 1, that a product of any number with 1 will always give itself that number. So if it is a letter, it will give you that letter. Then The sum of any number and its negative is always 0. Okay. Then this one, a times a to the power negative 1 will always give you 1. Remember the laws of indices. A to the power 1, negative 1 is the same as 1 over a. So a times 1 over a. So a will cancel this a, so it will always give you 1 times 1 is 1. Okay. Now, apply the distributive law of multiplication over addition to expand the following. So if you are to check, that's how we were calculating before. So this one will be easier to do. That's what we were doing or that time, whereby we'll move bracket by bracket, bracket by bracket, bracket by bracket. Okay. Same applies. So if you are to look at this one, is it a commutative A? Is it a commutative or an associative law?
Commutative. No, no.
Commutative.
They're saying it's commutative.
Yes.
Yes, Mashlapan.
It's associative.
It's associative. Okay. Because remember,
It's commutative, I meant to say.
it's commutative.
Yes.
Remember what I said. We said if it is A plus B, right? For commutative is equals to B plus
Yes.
A.
Yes.
Yeah. So remember associative, you need to have
A multiplication.
That one is
it's the same. This one is associative because we are saying 2 plus
Okay.
5 plus this one is also the same as that one. This one is associative. Why? Because we are, remember, we are saying A plus B
B
plus C
plus
is
C.
equals to, is the same as what? A plus
A plus B.
B plus C, or the same. So this one is associative. Why? We are just moving, but even if you are to look, it's kind of also commutative. Why? Because it's giving the same also this one. So I would say it's both associative and commutative. Same applies with this one, but it's addition, right? Same applies with this and this. All right, let's just move. Then fractions. Some people, they are also confused with fractions. Take note that the above is the numerator and the below is the denominator. Okay. Then we have got proper fractions. Proper fractions, the numerator is less than the denominator. Improper fraction, the denominator is greater than the numerator is greater than the denominator. That's improper fraction. Okay. Then mixed fraction, we have got an integer or a whole number together with a fraction. Then equivalent fractions, these are the ones whereby you can reduce this one to its lowest in its simplest form, and it will give you this one. Then reciprocal is just the opposite. So the reciprocal of 1 over 10 is 10. So in other words, if we have got 4 over 3, the reciprocal of 4 over 3 is just 3 over 4. You just flip. Okay. And the product of reciprocal numbers will always be 1. So this times this into this, then it will give you 1. Okay. Nothing much. All right. Can we do this one? At Beckville Secondary School, there are 14 female teachers and 11 male teachers. What fraction of the teachers is male? How do you calculate this one? Yes, Marsha.
14
Mandla.
plus 11.
Sorry?
First, okay. First, we must add the male and the female,
Okay, so
which is
14 plus
would give
11.
which gives us 20, which gives us 25. Then they say what fraction of the teachers is
Mhm.
over 25.
Yeah, that's it. All right. Let's move. Okay. All right. So sometimes they say change this mixed fraction to improper fraction. So what you do, first you multiply 3 by this whole number. So 3 times 1, that's 3. Then you add this one plus 4 plus 1 over 3. So it will be 4 over 3. So to change this one also, 3, how many times does 3 enter into 4? 1, remainder 1, then over the denominator. That's
Yes.
how you change. Okay. This is what I did. Can we do this?
Proper fraction, so 1 to a mixed number. 2
Mhm.
into 7 plus 8 plus 3 and 1 over 2. Okay. Can I try it?
Yes. Yes, we are listening.
Oh, sorry. I think it will be the answer is 3 and 1 over 2.
Yeah, simple stuff. Okay. That's it. Determine the value of A here. What do we do? A over 3 is equals to 16 over 24. Yes, Mashlakwan.
We cross multiply.
Okay. 24A
A multiplied by
is equals to
multiplied by
16 times 3.
yes,
What is 16 times 3?
48.
All right, 16 times 3. For the case of those who are following, 24A is equals to 48. Then we
Yes, then we
divide both
divide by
sides by 24.
Okay.
Then we get a equals to 2.
Equals to 2.
Yeah, the other way also is that you just reduce this one as well. Which are the highest common factor of 16 and 24?
Over 8.
That's 8, right? So
Yeah, both.
Yeah.
this 2 over 3. So meaning to say if the bases are the same, meaning to say A is equals to 2.
Okay.
Yeah. Then reciprocal. You're laughing. There are many ways to kill a cat.
I'm following you.
The reciprocal of one of this is what?
It's 7 over 10, 110.
Yeah, that's it. Simple stuff. So reducing fraction, there's what is known as the greatest common factor or the highest common factor. Reduce a fraction to its lowest term by finding an equivalent fraction in which the numerator and denominator are as small as possible. That's what we did that time. So you see, like given this 20 over 60, right? So sometimes what you do if you want to find the obviously this one you can just cross and 2, 1, then 3. You can get that. So the other thing that you can do is remember when you are looking for factors. So we start with 2, 2 into 20, 10, 2 into 10, 5, then 5 into 5, 1. So this we are reducing this into prime factors, right? So we are saying 20 is the same as 2 times 2 times 5, right? Then for 30, we do the same for 30. 2 into 30, 15. The other one, 3 into 15, 5. So 5 into 5, 1. Right. So we've got 60 is equals to 2 times 3 times 5. Right. So now when you are looking for the highest common factor of 20 and 60, obviously you get what? This one is with this one. So we've got 2, right? Times. Then the other one, which are common, is what? 5 and 5 times 5.
Sorry to distract you. I think you
Ah.
have made a mistake there. You to distract you. I think you made a
Ah.
mistake. You were using 30 instead of 60. Do you see the where you were
Oh,
calculating?
thank you so
That
much.
is why it won't balance. Yeah.
Thank you so much for that.
You're welcome.
Yes, this is 60. So 2 into 60, that's 30. 2 into 30, 15. 3 into 5, 15, 5, then 5, 1. So let's just fix this. So 2 times 2 times 3 times 5. Okay. So now we look the factors that are common everywhere. So HCF or GCF is equals to, here we've got 2 times, here we've got 2 again, times, we've got 5. So 2 times 2, 4, 4 times 5, 20. Okay. So meaning to say our highest common factor of this is 20. So now you then just come here and say 20 over 60, right? So you now 20 into 20, 1, 20 into 60, 3. So you get your answer here. So it's just necessary, especially when you want to reduce. But sometimes you can use your calculator so that you can beat time. But it just helps to, same applies here what we did. You can just reduce using those prime factors. Okay. Then we want to multiply these fractions. So the first thing that you need to do is to make sure that if there is a mixed fraction, you change it into an improper fraction. And we said, how do we change this one? So we do 3 times 2, 6, 6 plus 2, 8. So 8 over 3 times 1 over 4 times 9 over 10. All right. So when you look at this one, you realize that 3 is a factor of 9, right? So you can reduce 3 into 3, that's 1. 3 into 3 into 9, that's 3. Then this one, 4 is a factor of 8. So you reduce this one, 0.41, 4 into 8, 2. Then 2 is a factor of what? Of 10. You reduce 1, and this one, 5. So your final answer will be 3 over 5. Okay? Right. That's the simplest. All right, let's do number 1. This one. Somebody?
Right.
Yeah.
Okay. We are starting by reducing, which is
Mm-hmm.
5 into 5 goes once.
Mm-hmm.
And then into 45 goes 9 times.
Okay. 9. Mm-hmm.
And then now we're looking at 12 and 15, which is 3 into 12 goes 4 times.
Mm-hmm.
And then 3 into 15 goes 5 times.
Okay.
Then we multiply our numerators, which is 1 times 5.
Mm-hmm. Right.
Over 4 times 9,
Mm-hmm.
which is 36, if I'm not mistaken.
Yeah. So this one, you cannot reduce it. So that would be the answer. Somebody
Okay.
to try number 3. Yeah. Don't be frightened by the big figures.
I think it's mixed numbers, ne? Or am I wrong?
Yeah.
Where we start by breaking it to become improper fraction, and then we
Yeah, that's let's move. Let's do it.
I'm not sure.
But you look at this one also, this number 1. you could see that 15 and 45, they are related.
Oh,
So you can reduce this one, 15
yeah.
into 1 and 15 into 3, into 45, 3. 3 times
It's
12,
3, yeah.
36, then 5. You can also
Okay.
reduce first, you can also reduce first and you can move on. All right. Yes, I saw a hand there. Let us hear another voice.
Okay.
Yes, sir.
Okay.
Mm-hmm.
The first number which is similar to 2 over 1. Then we say times, okay.
Uh-huh.
Then, okay, the times 4 over 34.
Mm-hmm.
Then on the 16, the whole number, 13 over 16, we will first multiply by 16 by 2, which is 32. Then we add the number 13, which is going to be 45 over 16.
Mm-hmm. Yeah.
Then now 4 and 16, 4 goes once, and into 16 goes 4 times.
Yes.
Then 2 goes once into 4
Mm-hmm.
is 2.
Okay.
Then it's going to be, then we add, we multiply the numerator, which is 1 and 45, which is 45.
Mm-hmm.
Then over then 30, 34 times 3, which is 68.
Yeah, that's it. Okay, so you cannot reduce it further. So for those who are using calculator, so you can punch this straight away. So 2 times this one, 4, then you look on your calculator where there is A over B. Automatically 4 will be up, then you press your down arrow, it's already there. 34. After this, you press your right arrow key, right, times. Then for you to have a mixed fraction, you see on the calculator here, A over B, some they might say X over Y, I don't know. But you see the one that is in red there. It says A and B over C. That one represents a mixed fraction. So if I press my 2, I press my second function or a shift, right? And I will press that one. Automatically, it will bring this out. Then 13, I'll press my down arrow, 16. Then afterwards, equals. Then it will give me the final answer. Okay. So you can also use your calculator to do that. All right, let's move. Okay. Oh, addition of fraction. You can even use the calculator. It can also give you the answers as well. You can try out, maybe for the sake of those who want to know once more. Let me bring my calculator up. So 5, my key, 3, over 4, my arrow, plus 2, shift, then 5 over 6, minus 7, 1 over 3. Then already it gives me this answer. Sometimes it might give you as an improper fraction. You just click here where it says change. Some calculators, they've got S, this arrow, this one, S like this, G. So you just click on that one. It will give you as a, like you see, if I do this, it will change. If I do this, it will also give me the decimal. All right. Okay. For those who want to do manually, 5 over 6, add plus 2 over 30. So what you look for is what they call the lowest common multiple. So the lowest common multiple, you use the same method that we used when we were calculating. So you look for the prime factors. So you have got 6, 2 into 6, 3, 3 into 3, 1. So for 6, we have got 2 times 3, right? Now, for 30, uh, 2 into 30, that's 15. 3 into 15, 5. 5 into 5, 1. So for 30, we've got 2 times 3 times 5. So when we are looking for the lowest common multiple, what you do, when you have got this one, if we take this one and this one, we consider it as 1. So it's 2 times this one and this one. We consider it as 1 times. Then we also look for the other factors that were not taken. So that's 5. So 2 times 3, that's 6. 6 times 3, that's 30. So the lowest common multiple for 6 and 30 is what? Is 30. So that's the one that you use as the common denominator. All right. So you then over 30. So 6 into 30, that's 5, right? Then 5 times this one plus 30 into 30, 1. 1 times 2, 2 times 1. So 5 times 5, 25, plus 2 times 1, that's 2 over 30. 25 plus 2 is 27 over 30. Then what is the highest common factor? Is 3. 3 into 27, 9. Into 30, 10. 9 over 10. That would be your answer. So that's what you do when you want to do it manually. Okay. Right. Okay, perfect. When we are subtracting, we use the same rule again. You look also, what will just change is the sign. Over 40 from is 3 over 16 minus. So you look for the lowest common multiple. Let me just do for the sake of others. 16, 2 into 16, 8. 2 into 8, 4. 2 into 4, 2. 2 into 2, 1. So for 16, we've got 2 times 2 times 2 times 2, right? Then for 40, 2 into 40, 20. 2 into 20, 10. 2 into 10, 5. 5 into 5, 1. So for 40, we've got 2 times 2 times 2 times 5. Now for our lowest common denominator, or the lowest common multiple of the denominator, 2 and 2, we'll consider it as 1. 2 and 2, we'll consider also as 1. Then 2 and 2, we consider it as what? As 1. Then we are left with 5 and the other 2. So times 2 times 5. That's how you look for the lowest common multiple. So 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 5, that's 80. So that's how you look for your lowest common denominator. That's 80. So here is equals to 80. 16 into 80, 5. 5 times 3 minus 40 into 80, 2. 2 times 15. So 5 times 3, 15, minus 2 times 15, 30 over 80. So 15 minus 30, that's minus 30 over 80. You can reduce this one. So your final answer will be minus 3 over 8. So that's what you do. Okay.
How did you get, sorry to disturb you, sir.
Uh-huh.
The 15 minus 30, you got the answer
So
30.
it's minus minus
15.
15.
Yeah,
Thank you. You are following. I like
you're
that.
welcome.
So we've got which one can go? Maybe we use so 15 over 80. We use 5. 5 into, that's minus 3. Then 5 into 18, that's 16. Yes. All right. That's it. Okay. So you can try out with the bigger ones, but I just use the calculator because the time we will not be waiting for you during the exam. All right. Decimals. This is decimals. Okay. This one is an integer. So we have got units, tens, and hundreds, thousands. 1000s as it goes bigger and bigger. Then after the unit, we've got 10, and it goes there. That's a decimal. After the comma, that's a decimal. Okay. All right. Okay. So if you are to convert a decimal to fraction, let's say you have got 0.25. So what you do is you put 1 before the comma, right? Then you put 0, 0. So in other words, this one as a fraction, it will be 25 over 100, like this. Then you reduce 25, then this one into 4. So this is what you do. No matter the number you are given, if it is 0.245, you just put your 1 here, 0, 0, 0. So it will be 245 over 1000. Then you reduce. That's how you convert. So can you do this one? 7.65 to a fraction. Anyone to try? Anyone to try? Where are you guys?
65 over 700.
Oh, so this one, what you do, remember what I said is, if you want to convert this one, yes, you might put the 7 aside, right? Then 65 over 100. Then you reduce this one. What do you get? 13 over 20. So it will be 7 and 13 over 20, right? But you can also simply do 1, 0, 0. So it will be 765 over 100. Then obviously it will give you back to this. But if you are using your calculator, then let's say even if you punch 7.65, 7.65, eh, 7.65, you see it. But if it doesn't give you this, it might return the decimal. You click on the change. It might give you this. You click on the change again. If it doesn't give you, then you need to press the second function and that button. Remember that I said it might be on your calculator SD. If it is Casio, then it will give you the answer. Right. So now when you are rounding, let me just say this, let's say you have got 3.469. If they say round to 2 decimal places, what they are simply saying is that you move 1, 2, right? And you look at the number after. If it is 5 or above, you add 1 to this one. But if it is below 5, then you discard this number and you return this one as it is. So remember, if they say nearest 100th, 100th is 10th, 100th. So to the nearest 100. So you look at this. If it is below 5, then you discard this. Then that's why they have this one. Tens, that's the first one. You look at this one. If it is below 5, you discard this one. So this will be the result. To the nearest unit, unit is this one before the comma, right? You check the number after. Is it above? Yes, it is above. So you add 1. So it will be this one. Then tens, this one. You look at this, it's above. So you add 1. So 240. To 3 decimal places. 1, 2, 3. This one is above. So you add 1. So it will be this. All right. So round off to the nearest 10th, 1 decimal place. Any to try?
Fourteen comma 32.
Sorry?
Eh?
Sorry, you say?
I said 14 comma 32.
All right. Because the 10th is this one, right? So we look at the number after, which is below 5. So we discard this. We discard this, my friend.
So it would be 14 comma 3.
Yes.
C.
Mm-hmm. So just take note, especially when they are asking to, what is it? So the moment they put 10th, no, that is after the comma. And the first one is the 10th, the second 100th, 1000th, 10,000th, and goes on and on and on. Then there is non-terminating decimals. These ones convert the fraction to a decimal number and round off your answer to 3 decimal places. So that's it. Then we've got recurring decimals. Calculate 3. Anyone to try? But 3. Yes, Manja.
It's 8 over 13.
Uh-huh.
Then we could divide by.
Like this.
Yes, then say 12 over. Okay, I'm still going to do it in a way that it's okay. 12 over 25. Then we okay.
Uh-huh.
Then now
Uh-huh.
on the we must change the sign.
Okay.
Which is 8 over 16
Times.
times
Mm-hmm.
25 over 12.
So we use the reciprocal of this one, right?
please.
Okay, yes.
Then let's say 8 times 25 is 200
Uh-huh.
over 13 times 12, which is 13 times 12 is 156.
Yes.
Then now, the number that can go proper into all is, I think it's going to be produced, or it's going to be one whole number.
It's gonna be
The answer is going to be one whole number, 44 over 156
44
over
over.
156.
Okay. This one seems like it can be reduced.
Okay.
Yeah.
Yes. Okay.
I think
Let's
11. 4.
4 over,
Yes.
okay.
So 4 into 44, that's 11 over 150 divided by 4, 39.
Okay.
Yeah, so this will be your answer. So you can even use your calculator just to do this. 200 divided by 156. Then it can give you this. Change. It might be this or that.
Okay.
Then if you want to punch this one on your calculator directly, you just, the fraction, this one, AB, let me clear, right? 8 over 30, right? Let's see if we put over again. No, it won't. So remove this. Then you just do divided by. Then you press again 12 over 25. Then it will give you the answer. Okay. This one. Yeah, fractions, we are done. Now we are on powers. Powers. So take note, any number to the power 0 is 1. And 0 to the power any number will always be 0. X must not be equal to 0. And 0 to the power 0 is 1. So anything to the power, even a to the power 0 must give you what? 1. Okay. Okay. So if you are to look, we've got the base, we've got the power. Sometimes they call it exponent. Okay, so this is the base and this is the exponent. So the exponent is the power raised to the exponent. The base is raised to the exponent. Okay. I want to see if they have given you something to do. All right. Yes, Manda. Oh, it's that time.
Oh,
All right.
sorry, I forgot to.
The properties, I want to see if they have included the properties. All right, they haven't. All right, let me just name them here. All right. So when you have got the same basis, right? Let's say you have a to the power 2 times a to the power 3. When you have got the same bases like this, what you do, you just simply do A is equals to 2 plus 3 to the power 2 plus 3. So which will be A to the power 5. So when you have got the same base, you just add the exponents, the powers only. Then when you are dividing A to the power 4 divided by A to the power 2, the base will remain the same, but you subtract the exponents, which will be A to the power 2. That's what you do. Then A to the power M to the power N, it will be A to the power M times N. Take note of that. I think that's all. Then A to the power negative 1 will be 1 over A. Okay? So take note of all of these. Take note of them. So you see here, all right, that one, I want to check any exercise, right? You see this one, 2x to the power 2 to the power 4 by w to the power 3 to the power 3 by x to the power 7 to the power 2. So using that simple rule, 2 by, we said we multiply the what? The bases, okay? The exponents. So 2 times 4, that's 8, right? Then w, 3 times 3, 9, by 7 times 2, here there's w, 14 by w. Then 2, remember, we are multiplying x times x. So what we do, x, 8 plus 14. Eight plus 14, all right? Because remember, I said A to the power 4 times A to the power 2. We just add the what? The base will remain the
Exponent.
same. Yes. So the base x, so we just add the exponent by this one also. This one is W 9 plus this one is to the power 1. So it will be 2x, 8 plus 14, 22.
22.
W to the power 10. That will be your answer. So don't be confused. So let's look for any exercise that is there. Right. Yeah. Let's do this one. 2a 3 to the power 4, 3/4 times 3a to the power quarter. Anyone to try? Normally, these are the types of the questions that, yes, Mashakwan, that normally comes.
We are going to say 2 multiplied by 6.
We've got 6 Uh-huh.
The same. Then the base are the same. We add the 1 and
Uh-huh.
over 4. Then we say 6a. Then we take the lowest common. There's 4. We say 4 divided by 4. It's 1. 1 multiplied by
Mm-hmm.
3 is 3. Divided by 4 is 4. 1 multiple 4 divided by 4 is 1. 1 multiplied by 1 it's 1. Then we say 3 plus 1 is 4. 4 over 4 is 1. Then the answer will be 6a because it's going to be
Yeah.
6a to the power 1.
Yeah, that's it. Anyone to try number 2? These are the type of the questions. If you have attempted your assignment number 1, you might have probably found this. Yes. Anyone to try
Well,
this?
we're going to start with the ones on the bracket.
Uh-huh.
Then we're going to say 5p squared q to the power 4.
You see, the
Then
brackets
we're going to
always comes
multiply.
back again. Yeah. So P, you are saying multiply? Hello? Are you still there? Somebody to chip in?
Can I try?
Yeah.
It will be 5p squared q4
Mm-hmm.
in brackets p
Mm-hmm.
a to the power 18.
Uh-huh.
Eh?
Yeah.
P to the power 18.
Mm-hmm.
And then q to the power 8.
Okay.
Yeah. And then it will equal to 5,
Uh-huh.
5p
Uh-huh.
20.
Yes. Suppose you are adding 2 and
Yes.
18. Mm-hmm.
And yes. And then q12.
Yeah. So that's it.
That's the answer.
Yeah. So don't be confused with all this. That's it. Mm. If it is equal to 5 marks, you have gotten yourself. Then the negative, remember we said is 1 over. So here we are. Can you try this one? No, let's go to, all right. Can you try this one? Number 2. Yes.
We are going to
Eh.
we're going to say 2 2 to the power 2 in x 3 multiplied by
This one is the same.
multiply 2 to the power x plus 2 all over 2 to the power 3 in brackets 2x. Then we are going to say 2 to the power 6x. Over 2 to the power 6x.
Let's move on.
And the base that is the base are the same opponents. The base are the same are going to have a bad network.
Yeah, we're hearing that.
Yes, the base are the same. We add the exponent. We say 2 to the power 6x plus x plus 2. In bracket divided by 6x divided by 2 to the power 6x. Then we are going to get 7x plus 2 over 2 to the power 6x. Then when we divide and the base are the same, we subtract the exponent. Then we are going to say 2 to the power 7x plus 2x minus 6x. Then we get 2 to the power x plus 2.
Yeah.
Then we say 2 to the power.
That's the answer.
That's your answer.
Yeah, is that the answer? That's the answer.
Yes, that's it. Yeah. Oh, this one they reduced it.
I wanted to reduce it again to 2 to the power 2.
Okay, this one they reduced it 4 times 2 to the power 8. Let's just see. Oh, yeah. Like what they did here is that 2 to the power x plus
multiplied
2,
by plus 2 to the power 2.
yeah, times, so times 2 to the power 2, which is 4
times
2 to the power x. Yeah. So you just play around with the bases. Okay. rules of for exponent 2 to the power 1 will always give you the number itself. 2 to the power 0 will always give you that the 1. All right. Same style. Yeah, so this is what we were talking about. They've given it at the end. Okay. So take note of this one. You see x to the power minus a over y to the power negative b is the same as y to the power b over x to the power a. Remember, it's just reciprocal. This one is just as 1 over x to the power a divided by 1 over y to the power b, 1 over x times y to the power b. This one, then it will be y to the power b over x to the power a. So take note of this. So this is the same thing. I believe we have covered this. All right, the last part that I wanted to deal with is the roots. In summary, whenever you see a square root sign, it simply say 2 root is the same as 2. When you see the other number 3 like this, what it simply mean is that this one, the root is the same as any, like, let's say we put a here, is the same as a to the power half. If we put a here, is the same as a to the power 1 over 3. If we put 5 here, is the same as a to the power 1 over 5. So take note of this. Okay. It will make sense later. This one, you can just use your calculator and do. So this properties, root a, b is the same as root a times root b. Then root a over root b is the same as root a over b. So take note of these ones as well. And root a plus b is not the same as root a plus root b. And also root a minus b is not the same as root a minus b. Okay. So take note of these. You might need them later. Remember, I said root a is the same as a to the power half, right? So if you have root a times root a is the same as a to the power half times a to the power half, then remember our properties is the same as a half plus half, which is a to the power 1. So which will give you a. So take note of this. Okay. Then the cube root of a number x is a number r to the power 3 is equals to x. So sometimes you use this to find the unknown term. To find the unknown terms. So let's take, for example, All right, let's, I just want to look something with the letters. Okay, so this is what I was explaining. Okay, right. Normally these ones, you see, root x to the power 9, y to the power 6 is cube root. So you transform it to x to the power 9, y to the power 6 to the power 1 over 3. So you just divide these numbers of the powers with what? With 3. So x, 3 into 9, that's 3. 3 into 6, that's 2. So this will be your answer. It's the same also as x to the power 9 times 1 over 3 times y to the power 6 times 1 over 3. So if you don't want many hassles, the number that is here, you divide it with the numbers that are the powers here. Then you get this. Try out this one. 4 x to the power 4, y to the power 8.
It will be x y to the power 2.
Yes, simple as that. So don't be confused with. So if you are given a number, you find the square root of that number first, then that's it. So you see this one, you might be given this number 64 to the power 2 over 3, but still you can use your calculator. Then it's the same as the fraction part is the one that you put here. Then 64 in brackets squared. This. Okay. So then that will be, so you square this, you get this, then the cube root of this, that will be 16. So this will assist you. Maybe you've got you have got a fraction like this. Maybe it's 2 over 5 like this. So you just put your 5 here, then your 64, then in brackets 2. If it is 3 here, you just put your to the power 3. Okay. So if you are using a calculator, some they make a mistake. Root, right? 196. You don't say immediately plus. If you do that, it will be extended. So if you say root 196, you press your arrow, your right arrow, then plus, then root 144. You got your answer. Or if you want to do it individually, root 196 is 14. You write your 14 plus root 144, that's 12 plus 12. Then you add the final answer, which is 26. Okay. Right. This one you divide first. Remember, this is the same as 100 divided by 4. But you can divide Then you root 100 over root 4, which is root 100 is 10. Then this one is what? 2. Then the answer will be 5. So even straight away, 100 divided by 4, 25. Root of 25,
25.
that's 5. Yeah. Try out this one, C over X. Yes?
Going to be 9 minus x squared over x.
X squared over X.
All inside the bracket. Squared.
Oh, like this.
The squared.
Squared or half.
Half, man. I meant to say. Then we multiply, we say 9 to the power half minus x squared multiplied by half all over x to the power half.
But this one is squared.
Oh, it's squared.
Yeah.
Yes. Yes, to
So
the
X squared.
multiply by half. So the half of 9 is 3. It's going to be 3 to the power 2. To the power 2 multiplied by half.
3 to the power 2.
Yes.
Yes.
Multiplied by half.
Squared.
Multiply by half.
Yes. Minus, then 2 times half, it's 1. Then it's going to be x to the power 1 over x. Okay. Then 3, it's going to be 3 minus x over x.
Over X. Do we all agree?
Yes, yes, yes. Then
Okay. So I heard somebody saying, let me check. So let's give the person some time. To feel Are you there, my friend? Because what I think, remember root 9 minus x squared is not the same as root 9 minus root x, which we might have done here. So this one is the same as root 9 minus x squared, right, over root x squared, which will always give us what? So I believe the answer might be root minus x squared over x. Remember the laws, remember. We said root 9 plus maybe x squared is not the same as root 9 plus root x squared. So this one won't be the answer, but I believe it might be this one. Got it?
Yeah. Exercise.
Maybe I'm wrong, but I believe so. Let me just go back a bit. Where are the, yeah. It's, you see, you simplify it as it is inside. But since we have got a variable and the other one is not, then we are not supposed to. Wait, did I leave it? Did I skip it? Yeah, you see this one. This. Remember I said, take note, the only thing that you can separate is when you are multiplying. Okay? So, roots. This one, ratios. I think we have done most of the parts, and we'll have another session and we'll continue from where we left. Then I believe you will be able to know what's happening. But today we've covered much. So thank you guys for stay tuned until this time. I will advise when will be our next lesson as well. Okay?
Okay.
So I will send you the recordings as well so that you will be able to practice as well from what we have done so far. And yeah, I believe it's going to be a fruitful journey for you guys. So don't worry, don't be intimidated
Sorry, sir,
by all these.
sorry, sir, before you